Hello, this is Math 140, day 5. The topic here is a simple pattern, the difference of two squares, which is really useful, happens all the time, and we'll do some applications. So first, the simple pattern, the difference of two squares. So it looks like this. Is equal to a minus b times a plus b. Anyone can FOIL that out and check it's actually true. So let's do examples for that. Factor the number 399. What? Well, you want to apply this difference of two squares. The difference of squares. And we can apply it because with an eagle eye, you can spot that 399 is 400 minus 1, and that is 20 square minus 1 square. So, piece of advice, it is useful to actually have memorized square numbers up to 20 squares, okay? It's sure in your calculator, and anybody can work that out. But to spot a pattern like this, you can't ask your calculator, spot me the pattern. It's best to recognize, hey, that's close to 400, and 400 is 20 square. Everything else is piece of cake, okay? So 20 square minus 1 square, that's our 399, is 20 minus 1 times 20 plus 1. So that's 19 times 21. And okay, then I can go in and say we want to factor it into prime numbers. This would be a 3 times a 7, and then it stops. And it saved me a lot of trouble working out what exactly is the prime factors of 399. The exact same technique now can be applied when we have polynomials. Factor 4x squared minus 25. Here, the squares a square, b square should be easier to spot, right? So pause the video. A is what? B is what? Pause it. Thought about it, 5 seconds, 10 seconds. And now you should have come up with A is 2x and B is 5. You can also use negative 2x and negative 5, but who wants that? Nobody. Will give the same answer. So it gives me the factorization, 4x squared minus 25 equals 2x minus 5 times 2x plus 5. Right, that's not too bad. Let's push the envelope a little further. Two variables. How about 4x squared y squared minus 9 x to the 4th z square. Wow. 3 variables, can we handle it? We just need to find an a and a b so that the first one is a square and the second one is b square, okay? So a is what? 2xy. And b is what? 3x square z. That'll do the trick. If you take the opposites, you will get the same answer eventually. But those two choices for a and b will do the trick. We have a square minus b square. So this 4x squared y squared minus 9x to the fourth z squared is equal to a minus b. That's 2xy minus 3x squared z times 2xy plus 3x squared z. Important, don't FOIL that out every time to check on it. It's just working because a squared minus b squared is a minus b times a plus b. Same pattern every time, but you should double check that your choices of a and b really work. So this is a squared minus b squared. It fits the pattern. Okay, so this is about the difference of two squares, and with polynomials, the a and the b are actually quite easy to spot. It's easier than with integers, where I had to be creative and come up with that 20 all by myself. But here, not too bad. So now an application about rationalizing denominators, that is simplifying fractions where we have square roots in the denominator. Now first, let's look at numbers. How about 1 plus square root 2 divided by 3 minus square root 2. It's a perfectly good fraction, but some people would argue it's not that nice, and we will try to find a form of that fraction which has no square roots in the denominator. So rationalize the denominator is the name of the topic. And the trick is multiply denominator, numerator, top and bottom, by 3 plus square root 2. That's what they call the conjugate. Of the denominator that you have. So whenever you see a square root, you replace the sign, you flip the sign in front of it. Here we get 3 plus square root 2. What happens? A miracle happens. 1 plus square root 2 divided by 3 minus square root 2 times 3 plus square root 2 divided by 3 plus square root 2. Top and bottom gets multiplied by the same quantities, so it stays the same value. What happens? When we multiply two fractions, we can multiply the two numerators and we multiply the two denominators, especially focus on the denominator. We see the pattern that we just had, a minus b times a plus b, except it's from right to left, okay? So this is a minus b, and that's a plus b. So what do we get as result? We get a squared minus b squared. So that's 9 minus 2. Just in parentheses for explanation down here. This is only about the denominators. My denominators are now, my denominator is now 9 minus 2, not a square root in there anymore. It's a 7. The numerator is messy, can't do anything about that. So that's going to be FOILed out. And that's 1 times 3, the two firsts. The outers are 1 times square root 2. Then there's a 3 times square root 2, a total of 4 times square root 2. And finally, square root 2 times square root 2, that's a 2. So the end result is 5 plus 4 square root 2 divided by 7. And that is arguably a bit nicer because the denominator is now not involving any square roots anymore. It's the same quantity as before, but in a nicer form. And it's useful also, not just for making it look better, but for other purposes. For example, when you compare two fractions and you want to decide are they maybe actually equal, then you want to bring them into a sort of a standard form, and the standard form means that the denominator should not have any square roots in it. Okay, let's do one more example for this, but now with a variable. So how about 3 plus square root x divided by 5 plus 2 times square root x. What do we do here? We multiply top and bottom by that conjugate. Of the denominator, which is 5 minus 2 times square root x. You replace the sign in front of the square root by the opposite. So what do we get? 3 plus square root x divided by 5 plus 2 square root x times 5 minus 2 square root x divided by 5 minus 2 square root x. And don't forget to imagine those parentheses before you actually do the multiplying. Okay, this is how we multiply fractions. And in the denominator, we have the same pattern as before, except this time the a plus b comes first, but that doesn't make a difference. It's still a squared minus b squared, which is 25 minus 4x. And the numerator, that's 15. And then we have square root x times 5 minus square root x times 6, so minus square root x in total. And finally, minus 2x. And we can't simplify that. But at least we got rid of the square roots in the denominator. So a nice application of this technique of rationalizing the denominator. Thank you for this one.